sequence, ore extraction rate, equipment allocation, life of the mines. You are working in an open pit that has been identified by geology and models the whole body. What is expected of you at this level is to schedule your operation from day one to the end of the lifespan of that mine. Because if you are not scheduling your operations, you didn't properly sequence your operation in the mines, the oil extraction rate, then equipment allocation, then your cost may be excessively high and may make you, when you look at your cash flow, it make you to not to recover the fund you have expended during the extractions of the ore. So for you to be properly safe and to ensure that all the money spent in the mine is properly, you have to follow a due diligence and follow the instructions highlighted in the mine design. And the main objective this open pit design is you have to maximize the economic returns, as I've said. That is, if you don't design your mines open pit, the open pit mine, you will not be able, I can say that, can maximize your economic return. When you look at your cash flow analysis, you discover that there's a lagging things that you're unable to meet up with. Maximize economic return is one of the criteria that inhabit that we are getting for an objective of the pit design. Then ensuring operational safety. This will ensure that you have a good gradient system, 8 to 10%. Then slope angle will be efficient and checked. Then geotechnical constraint will be checked. And at the same time, water drainage will equally put to check. Ensure operational safety and achieve a good slope stability. Then you will be able to follow critically, efficiently and diligently the environmental impact assessment instruction that you're supposed to follow. Then you will be able to now optimize your oil recovery. You see that by the time you face and you do properly, the open pit design is going to enhance your optimize how you can recover properly your oil design. There's a typical pit design workflow. From I've said it earlier that geological modeling is key, which they have shown and they have located our ore where they are. And it is now considering our stripping ratio value. What is the distance of this ore to the surface of the earth, or to the surface? Now you are now going to consider, you are looking at your overburden, which is your waste to the ore. Is it economical to mine in open pit or to use other method of mine? The design will itemize it for you from the geological model that have been taken from geology, from as a result of their exploration, where mineral economics will have worked on and tell us the ore grade and tell us all the necessary parameter that we have to need to consider. And at the same time, resource estimations. This resource estimation will have been come up with the exploration report. This will now guide us that, okay, the value of what is on the ground that we want to mine through the open pit, after deploying all the machinery and the personnel and calculate the cost, is now going to guide us whether what we want to venture into is going to be economically viable and going to be achieved and going to be this is. So at this level, resource estimations will guide you to say that, okay, it is something we can do, that we can gain, and it is something that it has at par. There's a lot of things you do at par, you will either gain or you lose. But this time around, you look at, that is where the mine design will now guide and advise accordingly. Then geotechnical investigations. The geotechnical investigations is going to guide on how you can design your bench. The bench you are going to do, the softness of the rock, the strength of that particular rock, where you want to create your bench, and the face angle and all other things to be considered. This is where the geotechnical investigations is going to help us. And the pit optimizations, what and what we need to do to ensure that 100% optimization, how equipment is going to be used optimally, the personnel, the adequate number of personnel to work, the adequate number of things to do, then the recovery is going to tell you that okay, for example, there are some area that you need just 10 machines, but the mine design will guide you that you only need 5. So you will be optimized or whatever, even the personnel, because this one is going to create a scheduling for you that this is number of people that are supposed to work on this field at this particular time. Then you detail pit and bench design. When you have been able to adequately get your the technical investigations to be able to do your pit design, how many bench are you going? Is it 2 or 3 or 4 or 5 or 6 or 7 or 8 or 10 before you get to your hard body? This is where it's going to be designed, and the angle at which the bench is going to be designed. This is what the mine design and open pit is going to ensure and give to you. Then the mine scheduling, as I've said, the number of to be the people, personnel to be detailed to work at a particular time is going to be emphasized and going to be detailed. The equipment, the operations, and all the costs that are going to be made available for the efficient and the safe recovery of the whole body. Then economic valuation is another part of it, this which is one of the things they have done in the resource estimations. So you go to look at your cash flow and might stand to gain from this extraction you want to do or not. Because there's the millions of discovery across the whole world, but because of the economic valuations make some of those discovery unextractable, is not efficiently economically safe for us to extract some type of recovery. Because when you go to other places, you say there is a go here, there is this thing, but there are they of economic values that if you deploy all the machinery or you use a modern mines operation to work there, are they going to be economically viable or feasible? At this level, that is what the people are now considering. And I've been able to give the design mechanism, the workflow, as in typical and figure 5. Uh, Now, finally, you now to ask that there's a geometry, because this thing involves a lot of calculations. When you want to simplify the pit geometry, often follow the slope relationship. How do you have to see that the angle, that is where you are going to use theta, that is h over y, that h stands for the slope angle, that b stands for the width of the bench, that is height of the angle. So you are going to look at it. In mining engineering, open pit design integrate geology, geotechnical engineering, mine economic and operation planning to create a sustainable, profitable mining operations. By the time we get to the series 4 lectures, I'm going to give you all the relevant calculations that you are going to make use of when you are designing your mines, from the open pit, underground pit, and how you can do your management, your drilling and blasting. I'm going to give all the relevant calculation and how it's going to be used with a relevant, a standard commercial mines uh, analysis. So common software that you will make use of when you are doing your pit design. There's a lot of software, but there's a different software that are applicable to every design. And this open pit define this one, we are going to consider the use of support. It's not a crack editions, because when you use a full laser support, it's going to show you the enables, or if you want to use it to design the slope angle, it's just for you to slot the angle you want to put. Then your gradient, you are going just one go to slot, it's going to give you you are going to enter your data and it's going to give you what you want. Then we have Vocant, is another newest method you can use when you are designing an open pit. Then we have data mine. It's a common one, but it's only the craft editions are on rise. It's everywhere. Then we have Wheatus, is another software that we can use when you are designing your open pit mines. I believe with this, been able to do justice to the mine designs of open pit mine when you want to extract ore body using an open pit method. On our next editions, we are going to consider underground mine design. Thank you very much for listening.
Thank you, sir.
Thank you so much to our everything for the insightful and engaging session. We sincerely appreciate the time, experience, and expertise knowledge shared with us today. I would like to extend our gratitude to all our participants, especially those who join us online, for your active participation and interest throughout the session. As we conclude, we kindly request that you take a few moments to complete the feedback form provided. The feedback is very important to us and will help us improve future training sessions. At this point, we will open the floor for questions and answers. If you have any questions, comments, or observations, please feel free to raise your hand or submit them to the chat box.
Question and answer.
Okay, now is question and answer section. So let's bring up our questions, our observations, and those on live chats. And you want to drop your questions in the live box, and there will be a feedback form provided as well. So after the training, so endeavor to help us review in areas that we can do better.
Answer. First question.
Okay.
So how do you manage slope stability in real time, and what warning signs do you look for?
Okay, you discover that what is very important is those ability. The technique people will be able to determine the strength of that rock for you because there's an angle of which your bends must be designed. That's 100%. There's an angle you must follow when you design your bench. So, but when you do the geotechnique, is to tell you how strong is the rock. It's just like if you are in most cases, if the rock is not too strong, then you have to reduce your stool stability. Instead of you to have higher length of the bench, then you have to reduce your stool stability. So if the geotechnical at this level is going to be the one that is going to assist you, because otherwise you are going to have collapse as the truck is moving within your bench created. We just see that bench one collapse to bench two. So but instead of this collapse, the technical will have tell you the strength of that material. Are they compact? Are they strong together? Can they be cut into blocks?
Thanks, sir. So, my question is, can open pit mining be converted to underground mining? And if it can, what are the factors that will show, oh, these are the kind of limitation the open pit has that we have to like convert to underground mining?
You see, if you are okay with what you are doing, open pit cannot be converted to underground mining. They say you just abandon, because in the sense that you already open it up, as we call it in mining engineering, we call it surface mining. So because what you determine in the first instance, geology have told you where the whole body is. They will have told you through their meaning, through their satellite imagery, or which confirm through drilling. The drilling will have confirmed that this thing are in this so 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 depth. Now at that level, when the drilling, because it's the best way to determine the presence of our body is drilling. Because from the time immemorial, the hole you think you are seeing through satellite might not be that hole. So you get. So what is important is that they will have told you this is the position of the hole. They already drilled to that. They will model it. So when they model it, they will tell you. Now you now see stripping ratio. This is where I use. You now look at the distance from the surface to that hole. Now if I have to employ excavator to be digging and go to that place, how many excavator will I going to use? Then what is the cost of each excavator? I look at it before I get to that ore body. But geology will determine if it is go deeper than, and now look at it, that this is the number of excavators, this is the number of machines to deploy to get to that ore body, and all other parameters, creatines, benches, creatines, water drainage, creating a lot of things that are associated with the parameter considered for safe open pit. You now thinking that okay, what is the what is how much to use to just use shaft? That is vertical things that you have to use underground. So if you now look, okay, because of using a shaft, so that we shaft is just like there's what we call a laser operation model, where a particular things happening to you is going to be identified through scan, but they are not going to shoot directly towards that thing without open you up. So that's why they will have seen the whole body, but you now use sap to project toward that whole body, and that is where the underground. Having consider all factors, and you see that it's not economical for you to go through open pit, because if you use all the machineries, all the things that you needed to put in place, you see that the grade of what you want to extract, the lifespan, and when you do the plus and minus, you are not likely to have good economical evaluations in terms of the resources. Then you now consider another option B. Despite that thing is so shallow than what you expect, now introduce a shaft which is underground. What is the cost of introducing a shaft? You now look at that, then you now choose one before you even start at all. Those considerations will have sit with a group of engineers, geotechnical engineering, geologists, mining engineers, civil, all of them will have sit, engineering geologists, everybody, mineral economics, everybody will have sat on the table and did the meeting and how discuss. Argument will come, then we are going to stand by the fact and the history of what have been done when considering this type of activities. So it's not something that we just say that this is what I'm using open pit. You got to a stage, then you abandon. You want to go, you cannot make money in some type of venture. Thank you.
Thank you so much, sir. We have some questions from our online participants. The first question asks in respect to quarry design. The question goes down. Say, what are the most common safety challenges in quarry operations? Then he asks again, and also what methods are used to estimate the lifespan of the quarry?
Okay, number one, the method you can use, there is a lot of methods you can use in estimate the lifespan of the quarry. Is that uh, I've not seen very rare quarry that you see that they actually did the right things in the evaluations of the result, because we are just going to look at the outcrop and it's beyond that. So you have to use IP resistivities to look at around the rocks. What is because there's a lot of, when you go to Cross River State now, that is where I can see that they use resistivity to determine the value estimate, rough estimate of the quarry, because they are overburdening that place in that region is very high. So, but what is supposed to use IP resistivities to check the overburden around, then you just have to sand it, geophysics. Geophysics is one of the best methods you use to do the IP. Then when you determine the length of that rock, but what is very essential and at the same time people don't use it, you have to call. When you call, you should be able to know the height, because you don't determine the height. The height we normally use is the one that you just use empirically, that you just use it as a phenomena. That's the height of this rock I can see, let's use 12. So, but if you want to do it normally as you're supposed to do, you're supposed to sand, you are supposed to do, because at this level, the when you are doing the water this thing in geophysics, they be able to tell you that at this social level you get to water at this low level, and almost most of it fails, few of it assumed to be correct. So drilling, which is the most accurate way of detecting the height of anything you want to do. So if you now use that one, you use your volumes times height times overall for you to be able to now know that is that is that on that one. If it is understandable or if it's not, person can call after the lecture. We'll be able to give him what is necessary about that. Then in designing a query, you said what is the considered problem, is it?
What are the most common safety challenges requiring operation?
A lot of common safety challenges, some people don't even design mining query operation. Every mines that I go, very few, except the one that they are just going to start drilling at any point without designing it. You have to look at the lower part of your bench of the stone before you start your drilling. You see some people dey just drill irregularly on the mine. You have to, but those are some of the challenges, because it is safety challenge. And when you want to start quarry operations, you have to look at where you want to, that's where the place, there is a plan. You have to do a plan, thorough plan, before you even started drilling. Where are you locating people, staff quarters, magazine, a lot of things. It must be far from the open, from the face or from the mining face. So a number not less than 500 meters apart when you want to use your pit. But some of the things we see these days, they don't even consider the distance. Even when people are running, when they want to blast, even irrespective of the system they want to use, whether none or they want to use cord or whatever, the safety distance you must go far from around 500 meters apart from the mining phase. And the creating of this, and at the same time, one of the challenges is that they don't consider water management so important in quarry. And when you see an abandoned quarry, that's why you see it to become a den of pythons, reptiles, and some dead things. Because you have to consider water management and follow the geological information. Even at quarrying, you have to consider the geological map when you are designing it. Because your geological map is going to tell you the drainage, how you are going to do. So when you are opening your quarry face, you should consider it. But we will not say, we just say that geological training map is just like, it's not like that for fun. It's for you to consider when you want to design a site like that, so that you will now be able to challenge your drilling, so that as water entering into your mind, it's going to go directly. It's not going to form like dam inside your distance, and when anybody fall into it, whatever, it's going to affect, it can cause death, can cause another thing. A lot of reptiles, python can go into it and some other thing. And at any time when you want to do your mind close, it's going to be very difficult for you, because you already created a lot of artificial. When you go to crossrock and Pape, you see a lot of presence of those things that are there. There's water put there. They didn't consider the water management there when they are designing their quarry, because by now, despite their expatriate, they didn't consider it. And these are the part of the regulatory part of the when the inspectorates are going around. They suppose is one of the things they're supposed to look at. Where is your design for this thing? How do you take care of your water? How is it going to empty your water from this mining pit in case there is anything? So these are some of the things that our inspectorate supposed to enforce and look at the mine design when anybody want to. My quarry is not a small thing that people will open, that people will just overlook. Some of these criteria are not being followed, and they're supposed to follow it for the safety of the people that are working and for the safety of the environment.
Thank you so much, sir. So we have more questions among the physical participants.
No questions online.
So we have another question from online participants.
Speak up.
Okay, we have another question from online participants that said, what factors to be considered before selecting a quarry site? And for open pit mining, please, what factor determines the economic peak limit of a surface mine?
Thank you. When you are open a quarry, the factor to be considered, number one, everything is extreme in Nigeria and mineral heart. Those factors. It must not be closer to the public utilities. It must not be closer to electricity, public dams, community, villages. At least it must be at least about 2 to 3 kilometers to where people are living. Even if development will come up to where you are working, you will have a safe distance to walk, because there is a level you can walk that when you are even blasting, it will not go anywhere. It's going to be falling into the pit, and it's not going to escalate to anywhere. But when you are starting a quarry, it is very important that you have a very good safe distance in opening your quarry very far from people's arounds. And that is one of the things you have to consider. It must not close to the hospital, it must not close to the road, it must not close to the NEPA office, it must not close to the dams for people that are using. So where there is a congestion and traffic movement of people, the opening of a quarry into that place is restricted in Nigeria and mineral hub. So also the safety bench you can go there, it depends on your ore. You know, if your ore formations depends the type of the length of the bench you have, because if it is very flat that is many, so it give you the opportunity to have a wider pit. So when you have a wider pit, there is no need for you to have a multiple bench that are going, because when you just have about 2 or 3 benches, it is going to go. Because when you operate in this place, you can operate because it's very wider. But when the type of your particular uh, outcrop is not wider, that is when you now determine you have a multiple bench. The bench your establishment or determination, it depends on your planning. You can go as far as you can if you are able to manage your bench very well. That is where the mind geometry comes in, and for you to be able to determine the theta angle, and for you to now be able to now say, okay, this is the height I can manage at any level. You must consider a lot of factors, water management, and a lot of safe distance, and some a lot of things that you have to consider that way.
Okay, we question from Mr. One. It says, is this a Nigerian mining company? And how does groundwater affect slopes stability in an open pit and what mitigating measures applies? Secondly, how do you determine